Hey guys, Professor Doney again for the last problem we're going to do here on vertical motion. This one is the we're going to be in the castle throwing stuff down at those below, or we're standing on a cliff and the launch and landing heights are different. So we're going to be up here, we're going to say 100 meters just for easy numbers. Throw it up at 20. It's going to go up above us, it's going to reach its peak, come to stop, gravity keeps pulling it, it's going to fall back down. It's going to fall down past us and it's going to land 100 meters below us. So how do we solve these problems? Again, the book, or most books, will use the delta y equation and try to solve the quadratic. Let's break it into the up part and down part. So the up part, throw it up at 20 meters per second. Let's find t up. Again, we're picking positive on the way up. That makes gravity negative down. So we say 0. Why do we say 0? Because when we throw it and it goes to its peak, the velocity for a brief moment goes to 0. It passes from positive to a negative. So that's 0. There's 20. There's minus 9.8. And there's t. We find that time up is going to be pretty much 2 seconds. Okay. Now we need to know y up, or how far does it go above us, still picking positive up. Delta y, v0t, half gt squared, 20 for 2 seconds. That's how long it took to get to the top, so we throw it, let it go for 2 seconds. Half minus 9.8, that's 2 squared, not a minus. That'll be 40, ends up being 4.9 times 4. That's 19.6. So 20.4 meters is how far it goes up. So that just is a throw up problem or a launch problem, no big deal. What we switch up now is that we go to the down part. Let me just get a different, totally missed that. The down part is where we're going to let it fall now from its peak, and since it falls from its peak, the velocity is 0 up here, it's going to fall down. Now how far do we let it fall? We let it fall back down the 20.4 meters to our hand, which is this distance, plus the additional 100 meters of the cliff, which is this distance. So it's going to fall 120.4 meters until it hits the bottom. So what we're going to do is solve it and let it fall that far. So let's do a drop problem. We're thinking positive down now. That makes gravity down also. Delta y v0t plus half gt squared. Oh, what awful handwriting. Should have been a doctor, right? 120.4 meters is how far we're going to let it drop. It falls from rest, so that's 0 times t plus half. It's a positive 9.8 because we're falling in the same direction it's moving, or gravity's in the same direction. And it becomes out to be t squared. T will then equal 120.4 divided by a 4.9. We have to take the square root of that. And 120.4 divided by 4.9 equals square root that. 4.96. That's how long it takes to fall all the way down from the top. So the total time in the air, if we would jump and do this instead of throwing it, would be the time up, which is 2 seconds, plus the 4.96 way down. 6.96 seconds is the total air time. Now lastly, if I want to know how fast it hits the ground, down here, once it comes back down, I can change this, change the color a little bit. What we can do is do v equals VO plus GT, positive down. Initial velocity is 0 plus gravity is 9.8 for 6.96 seconds. We let it fall. That comes out to be, let's see, times 9.8, 68.2 meters per second. Obviously downward because we're picking that direction. That tells us how fast it will hit. So there's a quick problem on if we throw it up above us, let it fall back down. Below us, how long it's in the air. Total air time, and then also just how fast it impacts the ground. Obviously it goes from 0 here. If we throw it up at 20, it's going 20 the opposite direction there, but when it hits the ground it's going 68.2, 130 plus miles an hour. So hope that helps. That finishes up our vertical motion. Next we're going to go two-dimensional.